Well, woohoo! Hackaday is sponsoring another 555 timer contest. Cool. All right. I am no stranger to the 555 timer or the contests. I was the winner in the utility category of the contest that was held back in 2011 that was run by Jerry Ellsworth and Chris Gamel. So, I've been pretty quiet since then, at least 555 wise. I haven't used it for much, but as a timing circuit in some of my retro computers when I wanted a slow clock, and a few other things here and there. But, okay, so there's another contest. So I thought, well, let's try something. And I got to thinking, all of the uses I've ever put the 555 to were analog circuits. And I got to wondering, what could I do digitally with one of these doohickeys? And I knew that there was an SR latch inside, if you look at the block diagram. And I got to thinking, well, there's an SR latch there. I wonder if I could put two of these together and somehow build master slave JK flip flop out of them and maybe a counter. Yeah, maybe. You've got most of the stuff we need right there. I mean, there are a couple of problems. There's no not Q output on the latch. We've got a Q out and we've got no not Q out. So we'll have to take care of that. So I sat down and I started designing. And here's what I came up with. This would be a single bit counter. Basically, it would divide whatever clock pulse frequency is coming in by 2 and output it to the next stage. But we need a lot of stuff to make this work. We need two 555s, of course. And we need some inverters. We need two inverters just to make up for the fact that there's no not Q output on the latches. And I need another inverter to invert the clock pulse from the first stage to the second stage. And I need some OR gates. So, boy, that's a lot of circuitry to put around the 555s. Then I got to thinking, how about, can I use 555s as the logic circuits, the other logic circuits in here? And sure enough, I can. Yeah, here's a 555 inverter circuit. It can be wired up and it makes a pretty decent inverter this way. Whatever logic signal you give it in, a 1 or a 0, you get the absolute opposite out. So, okay, so I can use more 555s to make my inverters. So I'll need 3 per stage for the inverters. Okay. For the OR gates, well, I decided I can just get away with diode-resistor OR gates. I don't really need anything else. They seem to work just fine for this functionality. I thought about using another 555 just to amplify the output, but it doesn't seem to be necessary. It does work just as it is without any sort of signal amplification. So with just a resistor and a couple of diodes, I can create an OR gate. So I'll need 4 of those per stage. And then, of course, I'll need a clock signal. And, of course, the obvious thing to use for that is another 555 chip. So, hey, this was starting to look like I could actually do this. I could come up with something that was going to work, at least on paper. Or KiCad, it works. So it was time to start prototyping to see if I could actually make it work. Okay, so here's my first prototype, and it works. It works. It's a real forest of DuPont wires there, but I've got 6 555 chips, one of them acting as a clock. I've got 4 diode resistor OR gates in there, and I don't know how well it's showing up on the video. But, okay, this is the clock right here, and this is the output of the counter. And it is blinking at 1/2 the clock speed. Maybe if I speed up the clock, it'll be more apparent. Yeah, I think that's more apparent now that That's blinking at half the speed of that. So, okay, so I've got a circuit that works. And I think my goal is going to be to make an 8-bit counter out of this. It's going to be very Christmassy with all those red blinking LEDs. So 8 bits. And I've been thinking, this prototype just isn't going to work. I'm not going to scale this up to 8 bits. These DuPont wires are floppy. They get snagged on things. They're unreliable. It makes it hard to find problems on the board in that forest of wires. So I'm going to have to neaten this up a lot. And if I neaten it up a lot, and I think I can get 2 counter stages per breadboard. So that means I'll need 4 breadboards and maybe put the clock on a separate clock breadboard. So yeah, that's what I'm going to do. So I'll start working on that. Alright, so I have rebuilt it and condensed it. So I've got a 2-bit counter now on one breadboard. There's no more DuPont wires except the few connecting the breadboard here to the external oscillator. So with 2 per breadboard, I only need to make 3 more like this, and I'm done. Simple, easy peasy. Well, not exactly. It turned out to be a little more difficult because I needed more of everything to finish this. I didn't have enough 555 chips. I didn't have enough breadboards. I didn't have enough diodes. I wasn't sure I had enough 10K resistors. I was scrounging around in my junk boxes looking for them. So, I'm ordering stuff. Well, there's a global supply chain issue going on. It's almost Christmas. Deliveries are running late and getting lost. It's one thing after another. And those weren't the only issues I faced. I had some others. Yeah, you. Then there's this certain cat who, when my back is turned, delights in getting up on the table where I'm working and pushing my stuff off onto the floor. Yeah, I had to repair a couple of boards that hit the floor hard. That's not helpful. Well, so here's an interesting problem I've hit along the way. This is the first production unit I made, and it works fine. And I've been using it to make exact copies. So I'm using it as an example and wiring up exact copies of it until I have 4 2-bit stages. So this is the number 4 of 4 right here. It's not working right. Look at that. It's kind of got a random blink pattern to this first stage. And I have been doing a lot of troubleshooting on this. Every component's good. Every component's in the right place. Every wire's in the right place. Everything is right. And if I just press on the board right here, it starts working correctly. And I have reseated all the components. I have moved the components over a little bit. See, if I take my finger off, it starts that random blink pattern again. I think I have a bad breadboard. I'm going to have to rebuild this thing on a new breadboard. This is what I get for buying the cheapest breadboards I can find on Amazon. I got to start buying better quality stuff. Well, that's better. I transferred every component and every wire over to a new breadboard, and it's working perfectly. So yeah, there's something wrong with the other breadboard. I'm just going to throw that one away. I'm glad I wasn't working on something a little more complicated, like one of my retro computing breadboard computers, or that fault would have driven me absolutely batty. Well, there's all 4 boards completed, plus the oscillator board. All I've got to do now is wire power between them and the clock signals, and we'll power it up and see if it's going to work. I've been using just a USB cable that goes to my laptop to power up the individual boards up till now. So let me get to wiring it up and we'll see if it all works. Well, there we are. All 8 stages are working. Got an 8-bit binary counter built entirely, almost entirely from 555 IC chips. That was a nice little challenge I gave myself, and I enjoyed building it. And I learned a little bit. about a little bit more about how to use the 555 chip that I didn't know before. So yeah, this was fun. And I hope somebody else can find this useful. It's possible to build logic chips out of 555 timer chips. So very cool. So this is my entry in the 555 contest, sponsored by Hackaday. And thank you for considering my entry. And Merry Christmas to all. And I think, you know, if I put these boards in a circle around the base of the Christmas tree, it would be very festive, because Christmas is just in like 3 days. So Merry Christmas to all, and to all a good night. Thank you. Bye.